So the first Auton I'm going to be going over today was our 9 block early season Auton. So essentially the way that this worked, as you can see up here, is it would go into the block trio and then the block duo, hit the middle goal, go back to the match splitter, go to the long goal, and then ram it. So I'll show a little video of that really quickly. Yep, so as you can see, it kind of just goes. It missed there because it's a development video. Get those blocks and then score them. So going over that Auton, one thing I'd like to add for context is that Auton did not use distance sensor resets because it didn't have it on the bot at the time. So he used local coordinates based on where it started. So the coordinates might seem a little bit off, but they use the same structure relatively, as you can see. One cool thing about this Auton is it actually had an anti-jam where you would tell it an amount of time to do, and it would attempt to anti-jam the blocks whenever it detected that the blocks were going. Actually, I don't think this was detecting anything. I think it was just moving the conveyor back and forth, kind of just holding them in place, trying not to get jammed. Yeah, so the way this Auton specifically worked, is it would start off by basically just setting the exhaust to indexing, which was like, for us, we had spent some time tuning this on different robots, but it was around 30 to 25% power in reverse, and that would be relatively good for indexing the blocks. And then we move the conveyor and the intake at full speed, because those were different motors at the time. And the first move was a move to pose, as we were on tractions, relatively simple. It had a pretty decent max speed at 65. When I say decent, I mean in the context of that it was relatively slow, and I did that for consistency because I didn't really know what I was doing. I had kind of just started programming Autons at this point. I had a little bit of experience in high stakes, but not a lot, so I didn't really know what I was doing. So I just tried to keep it consistent. And then the next thing was our early exit range on the second movement, and that was so that it could continue at speed, and it would set down oh my god, what's it called? It would basically like flap down the match loader. I don't think it's in this one specifically, but yeah. Oh, it's because this is this is actually a different all time. But yeah, whatever. Same thing. And then it would, imagine that this says like middle goal. It would basically drive to there. It was the same thing with the movement. It was a move to pose, and I kept the default lead parameter because the lead of 0.4 worked relatively well for that movement. And then it would drive back to the match loader, also using another move to pose. Yeah, and then it would go, and yeah, it would go back to the match loader. It'd go up to the goal. All these are all move to pose movements simply because they worked, and since it was driving relatively slowly, it didn't really matter. Yeah, and we had kind of undertuned PID at the time, so that would also make a difference. One thing I do want to talk about is that for match loaders, I used like straight timing commands. I know some teams used sensors on their match loaders to detect the amount of blocks that were going in. My issue with that is that like they would probably still have, or the teams I talked to would still have some sort of timeout functionality. So at the end of the day, it was redundant, and I think the big issue was just making your match loader consistent, which I know was hard for some teams at the beginning of the season, as I know it was for us. We actually had a pretty decent match loader, but like just trying to get that consistent physically, I think was a bigger deal than making a like odd programmatic solution to that. So I basically just stop at a match loader for a certain amount of time, do what it needs to do, and then drive there. And then I would let the robot stop itself using just like the PID movements. Nothing really. This is a really simple Auton, so it was nothing that complicated. Yeah, so as you can see here, the intake and then some indexing on the conveyor, moves to the long goal, does some anti-jam on the way because the async parameter was set to true. Wait until done. That's basically just waiting. That's basically just joining the thread and making the call synchronous again. And then move it full power, just to score at full power. And then I would use the tank command timed to do the ramming blocks. I did that because I could control the amount of voltage going, or voltage percentage, which is what this is in a domain of 127 going into the motors. So it was able to, that was simpler than telling it to move backwards or move forwards with min speed. That's a really like unnecessary call when all you're really doing is moving back for a couple inches and going forward. It was kind of jarring, and obviously like it would tilt the robot up a little bit sometimes, but I think if I had relatively good cog, it wouldn't have made a whole lot of difference. Yeah, so that's going over like the basics of that Auton specifically. it was relatively simple, and it was a good auton for our first two competitions. We won our first competition with it. The second competition, interesting story when we got called out of size for being eighth of an inch out of size, but that's irrelevant, right? So yeah,